Hi, everybody. Good to see you all, or hope that you're out there and that you're going to be looking at this video. Some of us may need it, some of us not. You have your annotated notes already, so you can look at those and follow them. They are sufficient for you to follow, but you might need just a little guidance or a little more explanation of what's happening, so that's why I'm here. So hopefully this video will help you understand what's going on in our lesson for Unit 4 and what we're going to be talking about as we move forward. So I'm going to share my screen. So we can see exactly what's happening here. So here's our Unit 4 notes, our home page. So here's our homework breakdown. The first thing I'm going to talk about in this video is going to be homework 15 for the fundamental counting principles. Some of us have already completed this homework, and that's great. But going through and making sure we understand that this is the basis of what's happening and what we're going to be using this as our foundation for this unit. So we're going to be looking at these different things. You're going to need your calculator for sure as you're working through the homework. So make sure that you have your calculator. As we're finding these things on the calculator, I will do my best to make sure that I try to explain to the best of my ability where these things are located on your calculator. If I cannot and you cannot find them, please make sure you know you can Google your calculator. Just put in your whatever your model calculator is, tell them what you're looking for, and a video I'm sure will pop up on YouTube for someone to come up and show you where that button is located. All right, so here we are looking at fundamental counting principles as our first slide. All right, so here we are looking at our chapter 6. Here's a definition of counting. And counting is just, of course, the number of ways to count an event or series of events that can happen. So as we move through, you'll see that we're going to be looking at different things. We're going to look at rolling a die, or tossing a coin, or pulling a card from a deck. We're going to be looking at how things can be picked, or how we can do the probability of things as we move forward. So looking at how the number of ways or possible outcomes can come out of a situation as they set it up for us. Here with this first thing, we're looking at tree diagrams and the fundamental counting principles. Now we're not going to really actually look at or use the tree diagrams. We're just showing how you can use different forms of techniques to find out the different ways of how to find the different outcomes, the number of outcomes of things can happen. But using a tree diagram, if you're familiar with it, a tree diagram, it looks just like a tree. That's why it's called a tree diagram. It's like a branch that branches out, and it actually is, the purpose of it is to list out what the outcomes look like. We don't really care what the outcomes look like. We just want to know how many outcomes, the different outcomes there are. So when we look at this situation they gave us in problem number 1, we're going to look at how it looks in a tree diagram form and then the fundamental counting principles, and we'll see that the fundamental counting principles would be the best way, a more precise way to find out just the number of possible outcomes that can happen in the situation. And that's what we're going to be focusing on in this unit. All right, so it says, suppose we want to know the total number of ways, again, the total number of ways we could get different outcomes if we rolled a 6-sided die and then tossed a coin. Now, if you've never rolled a die, you've at least seen the dice before. You know, dice comes in a pair of 2. That's dice. When you look at one of them, it's called a die, all right? And it's a standard die, 6-sided. You will see that they will change it up and give you an 8-sided or a 6-sided or a 7-sided. You'll just follow what they say. But if they don't tell you in the write-up, you have to assume they're talking about a basic 6-sided die. Okay, so that's standard. And then, of course, tossing a coin, you have only 2 different sides, a head and a tail. So when we're looking at a tree diagram again is kind of rooted in itself. So you have to anchor it down somewhere. So here's the anchor, right? And the first situation they give us is rolling the six-sided die. So that's the first thing that we want to do or take care of. So coming from this rooted point, we're going to branch out 6 times, representing those 6 times we rolled that die. Try to see if I can get it as even as possible here. All right. So here we have 1, 2, 3, 4, 5, 6. 6 possible outcomes there for rolling that six-sided die. We agree with that, right? So here is us rolling the die. Those are our possible outcomes there. Then they said our second situation, they want us to toss a coin. So for every time we roll a die, we're going to toss a coin. So we roll a die and we get a 1. For that time we roll the die, going to branch out, and we can get heads or tail. So when we toss a coin, we only have 2 possible outcomes there, head and tail. Same with this second outcome here. You'll get option of head or tail. And this goes all the way down until you get here, all the way down to your 6th outcome where you get head or tail. All right. Now when you look, here is our coin. All right, so now when you go forward, now they're asking us to look at what's happening. So now they want you to list out, here's our list now of the possible, of the different outcomes. Now we don't really care about this, but this is what the tree diagram does. It actually tells you what the outcomes look like. So when you have this first situation here, you're going to have 1 head, 1 tail. Then here you have 2 heads, 2 tails. Here you would have 3 heads, 3 tails. And going all the way down, following the same pattern until you get all the way down to 6 heads, 6 tails. Right? So when you add up all of your possible outcomes, you'll find out that you have a total of 12 ways. Right? 12 ways that you can possibly get these different outcomes. Now that's a lot. When you're looking at using this tree diagram, what if they added a 3rd situation or a 4th situation? Then you're going to have a whole lot of branches, things piling up. And then that's too many things to reach out and try to order. And again, we don't care what the actual setup looks like. We don't care what the outcomes look like. We just want to know how many ways. The fundamental counting principles simplifies everything for us. It just simply says we're going to take and multiply the number of outcomes or number of ways, choices that we have for each topic. We're going to multiply those things together, and that's going to give us the total number. So with our fundamental counting principles, we have the 6-sided die, and then we have the coin toss. So since we have 2 different events, we're going to have 2 lines. 1 line representing each event. We have multiplication holding them together. The first line represents our die toss. And then the second line is our coin toss. How many choices do we have for our die toss? Would be 6. How many choices do we have for our coin toss? 2. When we multiply those together, it gives us our 12 possible ways. You see how this is much more simpler. than actually using this tree diagram to branch out and write out what those 12 ways look like. Again, we don't care what the ways look like. We just want to know how many outcomes we're looking at. All right. So that's why we're not really going to be using this tree diagram. I'm not going to test you on it. I'm not going to ask you to do it in the homework. All right. Just a comparison in the notes to show you why it's not really in an efficient form for us in this lesson. Here we are with our second example. It says, suppose we want to know the total number of ways we could get different outcomes if we draw one card from a standard 52 card deck, then toss a coin, then roll a die. So you see they have three different things going on here. Here they're asking us, oh, let's see what it looks like with the tree diagram. Won't do it. No. But what we will do is use this fundamental counting principles. We need 3 lines. Here's my multiplication in between. The first line represents our cards. Then the second one, our coins toss, and then our die on the end. Now let me put a pin in it right here. The 52 card deck. If you've never looked at a deck of cards, you've never played cards before, you don't know anything about cards, don't worry. You're going to learn about it in this lesson. And on the test, the only thing I'm going to give you is a picture of the deck of cards. I'm going to tell you what the suits are, the names, going to know how many cards are in a suit. And then that way you'll be able to count and know how many. But just know that 52 cards is the standard number of cards in a deck. Okay? And then we're going to break it down a little further as we go along, because then it's going to get a little more specific for us. Okay? But just know that for right now. All right, so now how many choices do we have for picking our cards? We have 52. We know that we have for our coin, we have 2. And for our die, you notice it says, then roll a die. It didn't say a 6-sided die, but it didn't say any other kind of die either. So right here, we automatically assume that it's a standard 6-sided die. So when we multiply this together, I've already done it in the notes. You've seen it too. Then we get a total number of 624 ways. Okay. So very simple. Just doing some multiplication of our numbers. Let's move to our next slide. Here's our next problem. Again, we got to read and understand what they're asking us. There are 12 photos that have been selected for my personal calendar. How many ways could I put my 12 photos in order before I send it off to the print shop? Now, here we have 12 photos that this person wants to put in their personal calendar. And we know a calendar consists of 12 months. Here's the key words. In order. Told us the total number that we have that we're counting or choosing from. So there's our structure right there. We're talking about a calendar. And we know that we got to put that in order. So we need 12 lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Here's my multiplication in between each one. All right. Now I'm going to write out the structure. Now here's my baseline structure. We know that each line represents a month. So starting off with our first month, we know it's January. This is February, March. And I won't write all of them, but we know it goes all the way to, let's say this is November and December. Okay. So all the way. Okay. Now, when she's looking at January, she has to choose one of these 12 pictures. How many choices does she have at January? She has 12. Then when she gets to February, she has how many choices? 11. And then, that's right. And then so forth and so on, right? So down to 9. And then, go ahead and tell it. Perfect. 4 and 3, 2 and 1. That's right. So now we've used up all the pictures, correct? Every month has a picture. So when we multiply all these numbers together, we'll see how many possible ways she can order these pictures to make her personal calendar. That's going to be a big number. So you're going to put it in your calculator, do the magic, and then the magic is going to tell us that it's going to be a big number. You should have 479, comma, 001, comma, 600 ways. That's a lot of ways to organize or create a calendar, okay? So thinking about the structure, what they're telling you, all right? Look at the setup. You may not do it. Some of us can do it in our heads. That's great. Sometimes you'll need to see it on paper. So think about it. Each line represents what activity or what thing you're doing. Okay, here we're talking about a calendar. We needed those 12 months. Let's look at what else. Number 4. It says, suppose I also want a separate quick reference calendar. So now this person, she already did a regular calendar. Now they want a quick reference calendar. But how do they want it? They want to organize it by fall semester, spring semester, and summer semester. 3 different semesters. That's our structure. Okay, 3 different semesters. Each semester gets 1 photo from the 12 that I selected from question number 3. So the 12 photos from the top there. Each semester is going to get 1 of those pictures, right, to be put or placed to represent those semesters. So now I need to put my 3 photos in order before I send it to the print shop. Total number of ways is what we're looking at. Here's my structure. I need a line representing each one of the semesters. So I need fall, spring, summer. Here's fall, spring, and summer. Okay? Now, from the 12, looking at fall, I have 12 to choose from, right? I need to put them in order. Here's my order. So fall, I have 12 to choose from. And in spring, now I only have, that's right, 11 to choose from. And in summer, I only have 10 to choose from. Now you notice we didn't need to use all the photos. There's 12 of them, but we only needed to choose 3. Okay? So now we multiply those numbers together. What did you get? Go ahead and do it in your calculator. I'll wait. Okay. All right. So you should get 1320 ways. Okay. 1,320 ways. Not too bad, right? Just evaluating the situation, right? And going based on it. Let's change it up a little bit. Number 5. It says, I must select the security code for my credit cards. We all have these. How many ways can I select my codes if each can have the following restrictions? Okay, so we have codes and they have restrictions. We all know that they have restrictions. They wanted to be this or that, or not have this, not have that. So follow along. Here's our structure where it's important. Discover card. 3 numbers. There it is, 3 numbers. 1, 2, 3. All right. What about these 3 numbers? The first number can't be a 0 or 1. Okay, so can't be 0 or a 1. Okay, then it says, and must end with a 0. So my last number must be 0. All right. There's our structure with our restrictions in place. Now we can fill it in. Now let's talk very briefly about how many digits we have. So now it says that the first one can't be a 0 or 1. So first thing first, we have to know how many counting digits we have. And we should all know that we have 10 counting digits. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 10 counting digits. We have to count 0 because 0 is a number, okay? So 10 counting digits. So that's what they're talking about. So the first one can't be a 0 or 1. So if we have 10 counting digits, but we can't use 0 or 1, that means that we only have 8 left to choose from. The second number here doesn't have any restrictions. So no restrictions, right? So this can be any one of those 10 digits, so 10 to choose from. But we know for sure that this last digit here has to be a 0. So you only have one choice. Is everybody good? All right, so now we can multiply these together and find out how many different codes we can get from these particular parameters. Now thinking about what they're telling you now, these parameters are very important. So after we finish reading, then you'll know exactly what's going on. So now we see that we have 80 ways to make this code. All right. Try the next one. This would be good to pause, okay? And then see if you can work it out for your Visa card. You have 4 numbers and no repetition is allowed. Think about it, no repetition. See if you can work it out. And then push play when you're ready to come back. All right. Here we are with our 4 numbers. So we need 4 lines. 1, 2, 3, 4. So then it says, no repetition is allowed. So if we have 10 counting digits, our first choice, we have 10 choices. For our second number, since there's no repetition allowed, then that only leaves us 9 to choose from. Then we have, that's right, 8 to choose from, and then 7. Good. Glad you got that. Then when you multiplied it together, you got, yes, that's what I got, 5,040. All right, 5,040 ways. All right, let's do our second one. Our C. Okay, correct that. C says MasterCard has 4 numbers, so we know we need 4 lines. 1, 2, 3, 4. Pause the video here, give it a try on your own, and we'll come back. All right. The first number must be a 5. So must be 5. All right, the last number must be a 0. Then it says no repetition is allowed. So fill in the ones you know for sure. We know that the first one must be a 5, so there's only one to choose from there. Then the last one here must be a 0. That's only one choice there. We've used up 2 numbers. That means we only have 8 numbers left. So for this next one, we only have 8 to choose from. And when we look at our next one, we have 7 to choose from, since we can't have any repeating numbers. So what's 8 times 7? 56 ways. All right, I hope you're feeling good about it. It's not too difficult once you read through it. Once you see what's happening, then you'll find a pattern and you'll see that it's pretty straightforward. Let's look at number 6. All right, it says, suppose I have a tag for my car, which has 3 letters followed by 3 numbers. Right there, they're telling you what your structure is. How many tags could be created with that pattern? Let's draw out the pattern. Here's my structure. All right, let's see. Okay, here's my pattern. 1, 2, 3 letters. 1, 2, 3 numbers. I'm going to put L under the letters and a number sign under numbers. So here's a letter, 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 and these are numbers. All right, so now I got my pattern, I got my structure, I'm ready to fill it in. Here's my multiplication signs. Make sure I remind myself that I am multiplying. How many letters do we have in the alphabet? 26, that's right. So, did it say anything in the problem about us having any restrictions on the letters? Nope. Didn't say that we couldn't have any repeating anything. Didn't say that anything had to start with a certain letter. So, we're good to go. So that means that how many letters do we have to choose from here? 26. And here we have 26. Here we also have 26 to choose from. Then we have our digits. Again, we know we have 10 of them. There's no restriction on those. So we have 10 times 10, and then 10 here. Is everybody good? Right? So now when we multiply all those, you're going to get a really big number. Go ahead and calculate it. I'll wait. How many tags could be created with this pattern? All right. That's right. Your number should start with the 1. So you have 17. Is it thousands? No. But 17 million. Ooh, that look good on a check, wouldn't it? 5,076. All right. So 17,576,000 tags. That's a lot of tags. Now, you probably have never thought about it. We drive our vehicles, our cars, our motorcycles, whatever, and we think there's a lot of vehicles on the road. But how many people have ever really thought of, I wonder how many tags there are in the world? It's a good question. All right, here we go. Number 7. Suppose I'm looking to buy a new vehicle. Some of you might be. There are 4 basic colors that I'm considering. I must have AC. I must have an automatic transmission. I will consider vehicles with or without a sunroof, and I will consider vehicles with or without trailer hitch capabilities. How many different vehicles could I possibly compare? Well, look at what they gave us. Now I know you see it, but take a second now and look through. How many things or categories did they give us to look at? I see color, AC, automatic transmission, that's 3 things now. Sunroof, that's 4. Trailer hitch is 5. 5 different things they gave us about this car. That means you need 5 lines. There's our structure. So we have 1, 2, 3, 4, 5. Here, 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 and here. So now, first line should be color. The second line, that's our AC. Our third line is automatic transmission. Our fourth line, sunroof. And then our fifth line, trailer hitch. Okay? We got our structure, got it labeled. Now let's see how many choices we have for these things. So color, they gave us 4 colors to choose from. It must have AC. That means there is no choice. Okay, so you only have 1 option there. Must have automatic transmission. Again, that's only 1 option. And then they said, I will consider with or without a sunroof. That's 2 choices for sunroof. And the same for the trailer hitch. Again, that's 2 choices. So now we multiply 4 times 2 times 2. That gives us 16 different vehicles. Okay. To look at. Make sense? All right. Let's look at our last one for today. Number 8. How many ways can I line up 5 customers at a bank? So here you are at the bank, and you want to line up these 5 people in a line. So we need 5 lines. 1, 2, 3, 4, 5. Each line represents a place. So this is first place, second, third, fourth, and fifth. Right? So here, starting off, you have 5 people to choose from for the first place. And then how many for the second place? 4. And then, that's right. And then 1. Perfect. Multiply those together and you get, what did you get? Yeah, me too. 120 ways you can arrange these people in a line. All right. So here we are. Finish practicing our fundamental counting principles for the first homework. Make sure you read the problem carefully. Make sure you watch the wording so you can see what your structure is going to be. Then make sure you look to see if they have any restrictions on the structure. Fill those in, and then you can fill in your choices for each category that you have. Multiply them together, and that's your answer. Good luck with everything. I'll see you at the next video.